start. So, this Material 2026 Magnus Conference. This picture basically the Laguna in Bangladesh, and in a smart way we called it the Tesla vehicle. So this is the common vehicle in South Asian countries. That's why I have chosen the topic, which is emerging sustainability vehicle for developing South Asian countries. And thanks to Metal 2026 and Magnus, and to show a platform like 9th edition of International Conference of Material Science and Engineering. So if I look at the EV market, which is defined as electrical vehicle, which has a dominant size in Asia, so that is a rapidly growing market, and just in specific Asia specific three-wheeler market, it has a 4.1%, which has a very much CAGR from 25 to 2033. And if you look at the graph chart that has been exported from the share market to all over the world, is almost $0.46 billion. And to the three-wheeler market, specifically in China, India, and the other region, from 2027, it was just $9.7 million, and now it has a rapid growth, and which comes to a $21 million. Okay, so country-wise, we can look over the status. We can show some market size, and we can focus on the electrical vehicle as well. So the green sizes are the Bangladesh, Nepal, and if I look at India, which has been marked at the red, because there's a prominent market which has about almost 7 to 8
Sorry,
billion
sorry, could you speak louder?
Oh,
Because
you
we
speak
don't hear
louder?
you.
Okay.
More louder. Yeah.
Okay. Now are you audible? Is it okay now?
It's
Okay.
okay.
So if you look at India, it has almost 2 million of sales on 2024, and rapidly it has been a very much rapid competition to the global market. Now, the main purpose of the study is a very high performance energy storage system for a particular electrical three-wheeler rickshaw, which is based on the lithium iron phosphate, and that has been never imagined in Bangladesh and in the South Asian region. The specific 3000 and the 217 cylindrical cells has to be replaced to a conventional 48 volt battery, and which is the ampere rating of 100 to 120 ampere. Now, in regular days, the lead acid battery, which is a battery pack of compact one, and compared to the lead acid batteries, which has the energy density of 30 to 40 watt hour per kg. This developed LFP package achieves an energy density of about 130 to 140 hour, nearly 35 to 40 weight reduction. So whenever you are riding a rickshaw or the Tesla, you can feel the weight balance and feel the drive cycle as well. The system allows 80 to 90% DOD, which is the depth of discharge, and they deliver more than the 3,500 to 4,000 tons discharge cycle at just 1C rate, which is nearby 4 to 5 times higher than the latest battery. Now, the main problem is we have a duration cycle that has been covered by the kilometer hour, and obviously this LFP pack covers to 70 to 80 kilometer, and with the 100 to 120 kilometer per charge under the standard load conditions. Assalamu alaikum and hello everyone. This is Abu M. Fuad, who is a senior lecturer of Department of Electronic Engineering, and right now I'm working as a consultant of the robotics and AI of the University of Scholars. And apart from that, I have building my research profile, which is focused on the energy storage and the combination of materials with AI. Now, here comes the stories of our country. This is the rickshaw garage owner, Mr. Milan Sarkar. Whenever we talked with him, he said to us that I cannot drive a paddle rickshaw at my age, but I could drive a rickshaw till 11 p.m. Which rickshaw? The question is to you. Now the another story, a person which has barely can manipulate or can manage a work with one hand. So this ease of use is of electrical importance to Abul Hussein. Yes, I'm talking about Abul Hussein, who used to work as a ceramic tile maker until a machine accident injured to his health in 2022. This is a real life story of Abul Hussein. They sacked me from the factory and only provided some treatment, and obviously the doctor had to cut off my whole hand. And this is the common scenario of factories in Bangladesh. And then I sold my little piece of land and I had him in a village for better treatment. He recalled that the 43 years old has a wife and 3 children to support. Now, how he may support his life along with his family? Very upset and thought about what to do after the accident. Finally, I took a loan from an NGO and bought an e-rickshaw, which is very much common in Bangladesh, called as Tesla car. And it requires hard work to drive a pedal rickshaw. So now the question is to you again, how he could manage a rickshaw with his one hand. The next story is about Raju. He is 18 years old, a rickshaw driver, and in Dhaka, old dialogue art, he told to the dialogue art that we do not want to struggle with the paddle rickshaw as they are very hard to drive and require physical strength. So during this storm, 3 people can sit on a pedal rickshaw, but they can affordably, comfortably ride in an electric rickshaw. So I have my parent with my siblings, so I have to pay 500 taka, which is equivalent to $4, and each day as a rent earn 70 to 80 taka, which is equivalent to 5.8 to $6, and this is the average of daily wage or the wages they have earned, not much more than that. So despite these regular attempts to Bangladesh e-rickshaw, the government's stance has not been consistent, because in February 2024, our ex or former minister, this is Nazrul Hamid, the state minister of power, energy and ministry resources, called that e-rickshaw is a Tesla of Bangladesh, and from that we call it Tesla. So he praised that the ingenuity of those making the vehicles, suggesting there are almost 4 million e-rickshaw, which is 40 lakhs. Can you imagine the size of the rickshaw? So in comparison to the United States, that's almost the twice population and almost the 3.5 electric vehicle in 2023, just in 2023. So now if I wrap up the whole summary of the whole scenario, in the global market, in the Colombia, Rwanda, Kenya, India, Indonesia, Philippines, Thailand, Bangladesh, Pakistan, so there are lots of experience and expeditious and largely informal growth in the number of electric three-wheelers. Popularly, these rickshaws, to the extent that any fleet of such vehicles is estimated to consist of approximately 1 million vehicles. Now the question is, it's very hard to control or to manipulate a rickshaw with a pedal. The person who are unable to control a rickshaw without the pedal and the person who are already aged, how they can manage. So here comes the concept of the e-rickshaw. Now the point is that most of the e-rickshaw driver are going to the lead acid battery, because the power management system and the battery energy storage is the most prominent, the most crucial thing for this particular vehicle. But here comes the main question. Who is our actual market and how they're going to involve in this? So already Palki has been involved with the electric market. Green Tiger has already been developed some electric scooter. Akish Motor has launched some electric cycle that has been renamed as electric bike, and they have some electric bike like Gixxer or F1 shape, but these are very much environment friendly. So according to this market, they are already been focused with the lead acid battery. Again, the question is the lead acid battery. This is called the powder battery in Bangladesh to the local market. Now the problem is, if you're going to the powder battery or the lead acid battery, it has a 300 to 500 charge cycles. Okay, it's obviously heavy and bulky, so you have a weight issue, and this charging time is what, 8 to 12 hours. I have already shown a picture that is the process of actual charging in Bangladesh, which is totally illegal, because we don't have any kind of charging stations properly that can e-rickshaw can operate and can charge their battery in time of free time, because all day they have to focus that we have to earn money. So whatever the rickshaw and whatever the battery management system. So and obviously the main problem is the voltage drops as it discharges is very much rapidly. And another question, needs water, tops up, and there are some obviously corrosion check. Now, if you look at the lithium battery, obviously lithium battery is far much better than the lead acid battery, which is a 70% lighter than that. Obviously, the charging structure is 2 to 3x faster and more powerful and longer playtime. I've already captured an image that has been portrayed the actual scenario that how this DOD, basically the depth of discharge, has been managed throughout the energy management system. Okay, now here comes the actual process of discharge and charge. Okay, And basically there's a separator which is used for avoiding the short circuit, and the whole process is from the cathode to anode and the anode to cathode while charging and discharging. And the actual discharging while using the load, basically we are carrying the passenger, so it basically flows from the anode to cathode as an electron throughout the load. Now VRLA, that is very much familiar as a latest battery, versus lithium ion versus LFP. So here comes my model, or my proposal. That is a very tiny model, that is 13,700. That is a single cell of 3.2 volt with the 6,000 mAh, which equivalent to 6 ampere hour. So it has a higher energy density, obviously better than NMC battery, and obviously it has some thermal stability that has not mentioned in the latest battery, and it has been promoted to the lithium ion but not much as LFP. Okay, so if you look at the drive cycle, or the charging and fast charging or discharging cycle at left side, that lead acid battery has been cut down from the 50%, and obviously there is no need to swap the battery when you're using the LFP or lithium ion. So in terms of choosing the best, we have to choose the LFP. So if we look at the scientific scenarios or the scientific executions, so there's a mathematical model which is the LET, this is lifetime energy through output. We can evaluate with the C times eta times DOD times n cycles, where the C is the basically the nominal pack, and eta is a round trip efficiency, and depth of charge I have already discussed it, which is very much common to the 80%. And obviously in terms of this calculation, we have to focus on the LCOE, which means levelized cost of energy. Okay, so just take some real life values that I have developed in my cycle in real life to find out the 48 volt and 120 ampere hour according to the equivalent lead acid battery, which is as equivalent to VRLA. So we have to pick 15 cell times 20p, basically 20 parallel and 15 series. So as a result, we can get 30 cells. So these 30 cells times 3.2 volt, as one cell is 3.2 volt, is equivalent to 48 volt. And C nominal, that is the capacity nominal, is 20 ampere, that is 6 ampere, and we're using parallelly 20 ampere. So you know, or you better know that obviously 2 times of C nominal will be 20 times C, which is 120 ampere hour. If there is some DOD times, or there are some issues of aging, then we can get it to 100 to 110 ampere hour in reality. So E nominal is obviously the same as 5.7 kilowatt hour, and the overall pack is 42 kg. Do you know, the question is, what is the actual weight when we're using the latest battery? 444. Basically 4 cells is equivalent to 12 volt, and one pack is equivalent almost near about 20 kg. So whenever you're using a battery of four packs, basically the whole system is almost near about 70 to 80 kg, and which is the reduction of 42 kg, almost more than 50%. So single cell energy is 19.2 watt hour, and as I have discussed the mathematical model, that is LEFT is almost 11,290 kilowatt hour, and the LET is almost the ratio of 2.5, which is a better result. Okay, so economic analysis according to the LFP lead acid battery. If you look at the cost analysis, I'm focusing the cost analysis, which is 188,000, which means $5,000. Now the question is, in Bangladesh or in the South Asian region, the owner or the rickshaw puller or the vehicle constructor, they usually think that I will buy a battery or buy a pack which is equivalent to 7 to 8,000. Okay, so 7 to 8,000 is one battery. So 4 batteries, what? 8 times into 4 is almost 30,000. So if I go for the 30,000, and these battery pack do not sustain more than 3 to 4 months, because they are not properly managed, they are not properly controlled, and they are not properly what? They're not properly in the combination of the authorities. So as a result, the efficiency reduced, the life cycle is not as much as LFP, and the cost comparison is too much, more than 58% less. And if you think in the bigger term, yes, I'm investing 188,000 BDT, which is almost 5,000 USD, but in a result, I can prolong this and I can use this from 8 to 10 years without any charge. But I am shifting the battery and swapping the battery almost after 3, 4, or 5 months. That's the more hassle and the more benefits that I have been explained with the economical aspects. So, to the aging behavior, I have discussed all the aging that according to the different phases, how it reacts. So basic the lithium ion phosphate battery comes to a LFP mine that has been common and which is invented in 1996, and day by day it gradually come to our life and make our life easier for the energy storage system. So here's the design of SolidWorks that has been constructed with a particular cell, and which is, if I put it in a lane, and I have assured that obviously it is not more than 42 kg, and obviously within this 560 to 750 millimeter in square. Okay, so this is the battery overall pack that has been simulated in Python. The pack will be something like this. So series 1 to 15 you have already noticed, and from 1 to 20 as a parallel. Okay, so this is the 3D view of my full battery pack, how it reacts with the particular battery management system. So overall comparison, obviously it is lighter and is smaller, and it has a standard of protection and BMS. Obviously it is non-toxic, and according to the environment friendly from 2022, from 2030, it has a less emissions rather than the other batteries. So here comes all the parameters and how it reacts and how it forms. So all the density, energy cycles, and discharge rate is obviously better results with better efficiencies from the cost per hour in typical uses of three-wheelers, especially for three-wheelers. So this is the model actually how it looks, and I have already discussed that the voltage of it, the current rating of it, and the usable energy, and obviously the pack mass of it. So according, it will gain some energy loss and obviously efficiency in 15% reduction. So I have already estimated the cost is almost 1530 USD dollar, and life cycle will be 8 years because it is a 200 to 2000 to 300 life cycles. So the performance conclude us that the lighter user and the lighter vehicle with the better efficiency, with better life cycle, with better investment is obviously the best choice. So according to the public health and environmental aspect, obviously it has a cycling process that has already been developed in some South Asian countries, and now it is in the growing market. And according to the low cost, it has a very informal recycle dominance. So why LP is better in terms of energy, in terms of environment, and in terms of what economy. So that's the charging state, then how it reacts, and according to the VRLA. And obviously, if I look down and deep down to the summarize the whole thing, the winner is the LFP pack with the 32,700 package. That's why we have to choose this LE FEPO4, that is the LFP package for our three-wheeler vehicle. Thank you.